record. So this is actually going to be a very short unit. It's going to take us 4 days to get through a data review and a test. If you are a senior, you're not going to take the test on this unit. It'll just show up on the final exam. The rest of you, we will have a test. I think that's Tuesday, May 27th on your new calendar. There was something else I was going to say about this. Because it's a short unit, I don't currently have any quizzes planned. We're just going to kind of learn stuff, review, and then take our quiz putting all this stuff together. So, sequences and series. Let me grab things over here. First section is sort of an introduction to these things. Then we'll spend a day talking about arithmetic, sequences and series. Hopefully that word sounds familiar. I'll remind you about that on Monday. Then a day talking about geometric sequences and series. And then one day talking about the binomial theorem and Pascal's triangle and how factorials can be used with that. Again, stuff you've seen. We'll try to push some things a little bit further than last year. But that's what I have to say. We are going to start by dealing with some stuff about sequences. What is a sequence? Yeah. And I think actually instead of set, I'm going to say a pattern of numbers. A sequence is a pattern of numbers. I'll give you a more formal definition in a moment. But for example, the sequence 1, 4, 7, 10, 13, and it keeps going. 1 is my first term, and the symbol we'll use for that, A sub 1. 4 is my second term, A sub 2, A sub 3, A sub 4, A sub 5. I've got my first term, second term, third term, fourth term, fifth term. Obviously, this can go on forever. I can talk about a general term of this as my nth term. Whose symbol would be A sub n. Doesn't stop there. We can have A sub n plus 1, A sub n plus 2. This is really just a notation thing. Let me give you the true definition, though, of a sequence. A sequence is really just a function. You got an input, you got an output. You plug in 1, you get 1. You plug in 2, you get 4. You plug in 3, you get 7. Plug in 4, you get 10, and so on. But the domain of a sequence is the set of positive integers. We can have a second term, a fifth term, but we can't have a 4.5 term. That's not going to make any sense. Our actual definition is a sequence is a function. Whose domain is the set of positive integers. I plug in a number, which will represent my term number, and I figure out, well, what is that term in the pattern? Again, with my pattern, if I plug in a 5, I get 13. Wouldn't make sense to plug in -3, 2.6, pi, any of those things. These are actually what we call discrete functions. Only discrete, specific values we can plug in. Okay, generating sequences. Let's find the first 5 terms of the sequence whose formula is A sub n equals 3n minus 4. Oftentimes, to describe a sequence, you'll be given a formula for that sequence, like this. I want to find the first term. the second term, the third term, the fourth term, the fifth term. Remind me what to do to find the first term. Ans, what do we do to find the first term? Aryan? Not 0. Plug in 1. The first term, my end value is 1. We're just going to go and we're going to plug in 1. 2 times 1 minus 4. You'll do that in a moment. How would you find your second term? What do you plug in? Oh my goodness, plug in 2. So you're plugging in work, especially because these are going to get more involved in a moment. I want to see where your numbers are coming from. But go plug in and let's generate those first 5 terms of this not terrible sequence. Alex, what's your first term? Sure. 3 minus 4. -1. Victoria, your second term.
2.
You're doing 6 minus 4. You're getting 2. Kirti, how about the third term?
5.
Yep. 9 minus 4. You've got 5. And Sasha, how about the fourth term? 8. 12 minus 4. You're getting 8. Ava, your fifth term? 11. Nope, minus 4 equals 11. Your pattern, -1, 2, 5, 8, 11. Looks like my pattern is we're going up by 3. May not always be an obvious thing to see. If I ask you what's the 100th term, is that any harder? No, you're just going to plug in 100 and that's it. The only way this gets tougher is if the formula is a little bit more involved to plug into. Let me give you one more of these. I want you to find the first 5 terms of a sub n equals -1 to the n over 3 to the n minus 1. It's going to be the same deal, though. Even though the formula itself is a little more complicated, you're going to plug into the top, you're going to plug into the bottom. By the way, I think these we should probably be able to handle without a calculator, but in general, we will use calculators for this unit, so you are welcome to get out your calculator. Let's go get A1, A2, A3, A4, A5. And again, just do show me that plugging in work. I will be looking for that. Connor, what's your first term? Yep. And Jack, how about the second term? 1/8. And Emily, your third term? Yep. And Genesis, how about that fourth term? Okay. Daniel, how about the fourth term? 1/80. Yep. 81 minus 1 will give you 80. And Arian, how about the fifth term? 243 minus 1, 242. Not a big deal. The formulas can get more involved. You're just plugging in numbers. Nothing too bad. Last year, you talked about two different types of formulas, explicit formulas and recursive formulas. Recursive where you plug in the previous term. There really isn't anything new with the recursive stuff, so we're not even going to really bother with that. It's not going to be in the homework, not going to be on the test. This unit's really going to be focusing on explicit formulas. Next thing we need to talk about, though, sometimes there's a strange sort of function that shows up in sequences and series, and this is called the factorial function. Before we go on, I do need to ask you a small favor. If you see on the top of that screen, top left, you see that like recording symbol, can you let me know, any of you let me know if it goes off? Sometimes it just stops in the middle of things, and I really don't want to have to record this like after school without you here. So let me know if it goes off. I'll try to watch as well. Factorials. You've talked about these before. What's the symbol for a factorial? Exclamation point. What does it mean? Yeah, we're going to multiply by all the previous positive integers. Which means we're going to end a multiplication problem with 1. Here's our actual definition. First of all, you can only take factorials of positive integers. There are like some calculus ways to extend it to decimals and stuff, but nothing that's going to be useful for us here. So we're going to say if n is a positive integer, n factorial is defined as, okay, so again, n with an exclamation point is our symbol. This means we're going to take n. We're going to multiply by one integer less, n minus 1. We're going to multiply by n minus 2. And you're just going to keep going down. And at some point, probably, you'll multiply by 2, and you'll multiply by 1. For example, if we're going to do the problem 5 factorial, what's this really doing? What's the math behind 5 factorial? That's it. 5 times 4 times 3 times 2 times 1. See if you can do that by hand. What is it? Just say it. 120? Yeah, it is. Let's go do 7 factorial. I think now it's time for me to show you the button on the calculator. We're really not going to use this a whole lot. We are going to do a whole lot of work by hand with these factorials. But to do 7 factorial on the calculator, do you remember where to find the factorial button? Maybe not button, really just function. You're going to type in 7 and then push math. We're going to go down to the probability pull down Factorials are used quite a bit with probability and counting things. Any of you who take statistics next year, you will definitely do a lot of stuff with factorials. I'm going to go down to option 4, 7 factorial. This is saving me the time of typing in 7 times 6 times 5 times 4 times 3 times 2 times 1. Should get 5,040 from that. I want to do some factorial simplifying by hand, though. Let's look at 6 factorial over 4 factorial. I want to do this without a calculator. And I think the way to do this without a calculator is to write out what these things mean. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial, 4 times 3 times 2 times 1. What do you see? What are we going to do? Ava? Yeah, we can cancel them. That's kind of the reason I wanted to write this out, so you could see we've got factors we can cancel. The 4s are gone, the 3s are gone, the 2s are gone, the 1s are gone. You should absolutely be able to do 6 factorial over 4 factorial without using a calculator. Answer is 30. Make sense? How about you go do 2 factorial times 6 factorial divided by 3 factorial times 5 factorial. And again, I want you doing this without a calculator. Who's got an answer they can share? Jack? 2? Yeah, I think so. Okay, so the 6 is going to stay 5, 4, 3, 2, 1. The 2 and the 1 are going to go. You're just getting 6 over 3. You're getting 2. How about you go do n factorial over n minus 2 factorial. See if you can figure out how this one's going to work. And obviously, you can't write out everything in n factorial. But I feel like you can probably write out enough things to figure out what this would get simplified to. Take a moment, do some thinking. Of course, feel free to check in with people nearby. Who can tell me what this becomes? Aryan. Yeah, do you see that everything n minus 2 and on is going to have to cancel here? That's just going to give you n minus 1. You dealt with factorials last year? Did you use factorials when you did like the binomial theorem, when you did like x plus 4 raised to the 6th? Does that look familiar, or is that going to be something new this year? We're not remembering things. Okay, good thing we're going to review that next week. There is one special sort of factorial, special case. Zero factorial. For various things to work, we have to define zero factorial to be something in particular. Anyone remember from last year what zero factorial is? Okay, go type it in on your calculator. It won't give you an error. Zero factorial is 1. We're going to define it as 1. Straight factorial problems like 5 factorial, 7 factorial, what this can actually calculate in the real world is how many ways you can line up 5 different things. You got 5 choices for the first spot, 4 choices for the next spot, 3 for the next one, and so on. Zero factorial is kind of like asking how many ways can you line up 0 things. Well, 1 way. There's nothing to line anything up. We just don't do anything. That's sort of maybe a meaning. We're going to need it to be defined as 1, though, for various calculations we'll get to when we try to do those expansions to work. Before we move on to series, I want to go back and have you do one last generate the sequence problem. I want you to find the first 5 terms of a sub n equals 2 to the n over n minus 1 factorial. Go figure out A1, A2, A3, A4, A5. And again, like always, show that plugging in work to get your numbers. And see if you can do this without a calculator. These are the terms in your pattern. 2, 4, 4, 8 thirds, 4 thirds. Anything at all on sequences? There are 2 special types of sequences called arithmetic and geometric. We are not going to bother with those for today. we'll spend time on those next week and talk about series and all that kind of stuff. I'm going to give you a moment to finish making notes, and then we're going to move on to series stuff. Okay, and before we do this, I'm going to stop this for a moment, because sometimes